So hello everybody. Once again, this is Torsten speaking from Inray. Thanks for joining. Good morning, good afternoon, good evening, wherever you might be located. Thank you very much for attending this basic training webinar. And yes, this is not a typical marketing webinar. It's really a basic training about how to handle OPC router, how to use the drag and drop technology, how to connect to an OPC server, for example, and transfer data to a database or into a CSV file. My colleague Andrea will guide you through that training and give you a live demonstration on how to handle the software. Before we start, I've just, for all of you who are new to OPC Router, very few and very high level slides about OPC Router, what it is and what it does. Before we start, this session will be recorded, and it would be great if you could mute your microphone and turn off your cameras just to ensure that we have enough performance and no noise interruptions during the session. If you should have any questions during the webinar, please feel free to enter these questions into the chat or contact your local OPC router expert. So we have globally several OPC router distributors with excellent OPC router knowledge. You can find them on our website. If you go into the menu on opcrouter.com and you go into the menu and click on international distributors, you will find the list with all our international partners per country. Please feel free to contact them or send us an email to sales@inray.de directly. Also, if you like the webinar and you would like to show it to one of your colleagues and you would like to see the recording, please just send us an email or contact your local OPC router partner, and we will provide you with a download link of the recorded webinar. And as I said, please feel free to ask your questions through the chat of Microsoft Teams. And while Andrea is presenting, I will try to answer these questions as good as possible, or try to ask the question to Andrea when there's a suitable time slot. Okay, as said, very few questions about OPC Router, what it is and what it does. Before we start I would think in about 3 minutes with a basic training webinar. So what is OPC Router? Because the name of the software might be a bit misleading, because people think OPC Router can only connect to OPC data sources or data targets, which is not the case. This is just a historical name, because in the 15 years ago when we started with OPC Router, the main data source has been an OPC server. Today we can connect almost any system with almost any other system. And router doesn't stand for a hardware solution. It's really a software-based communication platform which transfers data between different kinds of systems. Doesn't matter if these are OT systems or IT systems, if it's an OPC server or a printer or a barcode reader or a labeling system or an RFID system on one side, and on the other side maybe an ERP solution, SAP, a cloud system, databases, whatever it may be. And I think that's the real power of OPC Router, to connect all these kinds of different solutions with each other via drag and drop, really simple, and in only one standardized software solution. So this is a typical marketing slide about the added values of OPC Router. I think you might have an idea what you will use it for and what kind of added value OPC Router might bring to you. For example, save time because of automated communication between different systems, because it can reflect logics and processes while transferring data, aggregate data before transferring the data, and so on. I think out of all these arguments, there are two main points that stand a bit out and make OPC Router pretty unique if you compare it to other kinds of communication solutions, for example, hardware-based connectivity solutions and routers, or other kinds of software solutions that connect different kinds of systems. One thing is what I've already mentioned is the ease of use, and this is something that you will see in Andreas' training in a second, because you really can connect different systems just via drag and drop. Pretty easy to do. So you don't need to be an expert in IT or in automation. You don't need to know how to script. You can do scripts if you like and if you need, but for simple connections, it's not needed. You just click your connections together, and that's it. And the other point that's really pretty unique is the number of available plugins and connectivity options that you have in just one single software platform. That is really pretty unique. While other systems might be able to speak maybe OPC, REST, MQTT, and maybe XML, OPC router includes more than 40 options to connect all your systems, and the number is growing fast. So we will have about 3 to 4 releases every year. With almost every release, we will add additional connectivity options and plugins. So the number is growing rapidly. And this is just as a visualization how such an OPC router connection or network and communication solution could look like. So we of course have customers that have pretty simple kinds of data transfers. For example, they are using it to transfer data from their field systems, from PLCs to a database. So if these field systems don't speak OPC, then they might use an OPC server in between, like a Kepware. As we are also Kepware distributor in Germany and Austria, we prefer Kepware because it's a very stable and very performant solution. So connecting to an OPC server, taking the data with an OPC client and transfer it to a database like Microsoft SQL Server, MySQL, Oracle, maybe also InfluxDB or MongoDB. So it doesn't matter which kind of database you would like to connect. So it's a pretty simple use case, but still a lot of customers are exactly using it for this. And there's another kind of typical customer that are using it really as a centralized communication platform to control communication processes. So for example, that the PLC just finishes a production order. So when finishing that production order and changing a bit in the PLC or changing the production order number, it can automatically communicate with an ERP solution like SAP or Oracle or Infor or Microsoft Dynamics, you name them. So it doesn't matter what kind of ERP system. Let's say customer is using SAP. So the PLC is connecting to SAP, requesting the next recipe or the next information about the next production order, including the amount of products that have to be produced, the recipe, the customer name, the product type, whatever kind of information you might need for production. So this information is then sent down through OPC router to the PLC. There is a mechanism to give a handshake back to the ERP solution, telling the ERP system that that information successfully has been transferred to the shop floor and the production will start now. Then the production is started and the field systems are doing their job. For example, there might be a packaging area where you have some label printers and these, so the PLC might send some information to the printer. For example, a barcode, product number, article number, quantity information, product type information that would be printed onto a pallet or onto a product. And then if there should be an issue, for example, that the connection to the printer fails, or the printer should run out of labels, or it should run out of ribbon or ink or something like that, So there's an issue. Then OPC router can also recognize that, get that information from the printer, or recognize that the connection to the printer is failing, and automatically can inform a maintenance team via email or via Telegram message. So this is something, for example, that can be used as one single process. And in parallel, of course, the data can also be transferred into another database, to a barcode reader, into a cloud system, and so on. And different kinds of data transfers can happen in parallel at the same time. And that's what OPC router is all about. That sounds, maybe it sounds complex, but it isn't. And you will see that now when Andrea now takes over and shares her desktop to start the basic training on how to use OPC router in real life.
Yeah, thank you, Torsten. So I now will present my desktop and share the screen where I have my OPC router on my virtual machine. And as you see, it's of course graphically, as Torsten told you, and we have a vertical menu on the left side, which we can step through to get our connections active. And of course, we also have a classic menu with files, extra, Windows, and so on. And if we start, I think someone has muted his microphone because I get some echo.
I just muted.
Okay, thank you. So, so we first start with the plugins part. The plugins part is where we can see all the available plugins that come with the OPC router installation per default. And we have it structured a bit so we can find it a bit more easy. So for example, if you want to connect to OPC servers, then we have a look at the shop floor part. There we can connect to OPC UA servers, for example. I have pre-configured my local CAP server installation. If I double click, or if you click on the plus, you can create a new one. You can give it a name. I call it CAP server X demo. And you can configure own certificates for securing the OPC UA communication. We have a legacy certificate that is used for all Inray products. So we propose to use an own certificate. You can directly create it using the plus button here, and you can view it or delete if you don't want to use it. It is can also be managed centralized. I will show you this later. And you can say whether you want to trust all server certificates coming with Windows or with router, or only with a router or in Windows certificates trust store. Of course, we need to insert the endpoint. This is, of course, the most important. We can then set the sample rate, how often the tags are polled. We can configure timeout. It's 15 seconds at the moment. But the next important thing is whether we want to use anonymous logon or use a specific user as I have configured it, and whether we want to use the highest available security level at OPC server, or if we want to configure some specific mode. In my case, I have configured it on the highest security level, using it with encryption and a signature. If you have two OPC servers in your environment which act as a redundant pair, then you can add, in addition to this primary OPC server, a secondary OPC server. So if the primary is not available, the OPC router would automatically step over to the second OPC server. So now we can check connection. We have inserted the endpoint. We have selected the certificate, use the specific user, and the specific security level, and connection is established. So you can click on OK. I just click cancel because I already prepared it before. So we have an OPC server available for our communication. If you would not use an OPC UA server, you also could use OPC Classic and connect to classic OPC DA OPC servers. In addition to the OPC server, we want to save some process values to a database in our training example today. So under storage, we also would add a database. In my case, it would be a relational Microsoft SQL database. You see there are more databases available. You also could use file-oriented databases or time series databases like Influx or MongoDB as a document-oriented database, but we use a little example with Microsoft SQL. And I have my training database here locally installed as SQL Express with a default port. If you have set the authentication correctly, then you can directly drop down and see, okay, communication is running, and you can select your database. Of course, you also can use check connection to test whether it works. Using Windows authentication or using a SQL user is something that you can decide, or your IT department decides. With Windows authentication, the OPC router uses its own Windows user with which in this case, the configuration is running, but on the runtime, the OPC router runtime is running. Normally, you log in with your Windows user on the configuration, but this router runtime is running with the service system user. So in some cases it would not work, or you must change the user under that the OPC router runtime is running. So in this case, when you have an OPC, not an OPC, an SQL server on another system, and the local system user has no usage rights there, then you also could use a specific SQL user here with username and password. Of course, we also have the possibility for the command timeout, so for selects, inserts, updates, and so on, and the connection timeout, so 60 seconds if the OPC router tries to connect to the SQL server. And the OPC router has the possibility to decide to use up to 10 parallel connections. This polling interval here is only necessary if you use the database trigger, so if you use the database as event source, and there is no event management in the data source available. Okay, so we have two systems that we can use for data transfer. So we can step forward to our connections tab. There we have the local servers, and we can create folders for structuring our project. So today I would call it basic training. And there we can create other subfolders, or we directly create a new connection. So in our first example, I would like to write the temperature of machine 1 to database table. We also can move this here to left and right to have more space. Now we have here the design environment, where the kind of paper where you can draw your connections. And on the right side, we have some data sources and destinations. I can make it small, so we also see the triggers. So what are the triggers for? The triggers decide when to transfer the data. So for example, if we have our temperature on OPC level, we have some OPC trigger available. And if the temperature changes, we want to save it to the database table. So we use the data change trigger in this example, and we double click to edit after we have moved it per drag and drop on the left side. And we can select the OPC server that we have prepared now. So it's the OPC TCP target from CAP server X demo. And the trigger item would be our temperature item. So we can use the 3 dots here to browse the OPC server. You can open the folders, or you can click here to search for some specific items. There's just an information that it could take some times according to capacity and number of structures in the OPC server. And then you can insert just a part of the name, and you will find all temperature items in your structure. In my example, I would use Machine 1 PLC process values current temperature. I just double click to insert it. You also can select and use the apply button if you prefer it. So then we can decide if you want to send the data at most array seconds or at less array seconds. In my example, it would be enough to say, okay, please trigger at a difference of 0.1 in absolute. For a floating point number for the temperature, I think this is a good idea. And we have some other possibilities here. For example, trigger if timestamp changed. So you also can trigger if not the value itself changed, but if in the PLC a new value is written, but the new value is the same like before, but the timestamp then changes, then we also can trigger this as a data change and activate this one. In my example, it is not necessary because we always get a new temperature value if we want to save to the database. And there's another possibility using the metadata output. Why do I do it? This is because normally a trigger only tells when to do data transfer. But in this example, we have just one data point. So why don't you directly use the properties of this element, the value, the quality ID? If you know OPC, you know that the quality tells us whether the OPC server could read the value from the PLC or not. So bad quality we couldn't read, good quality we could read it. And we have the value time, and we have the item name if we need to write it anywhere. So we also have a data source here. We have a data change trigger, and it also acts as data source in our example, and we want to directly save it to a database. So we use our data sources and destinations, and there we see we have the database transfer object, and we just drag and drop it here, leave the mouse button where I want to place it, double click, and I can select my database. And I can select the type, what we want to do with this object. So whether we want to select data, insert data, update, delete, or even call a stored procedure. Of course, we want to save our temperature to the database. So it would be an insert that we would technically do to the SQL table. Then we can select the view or table. We make an insert, so we use a table, not a view normally. And the table I use is the process values table. There we have the value, we have the quality. You see it's integer 32, so we would use the quality ID instead of the string then. We have the UTC timestamp column because the timestamp will be in UTC. And we have a column called config ID because we also want to save what is the real source. Is it a temperature from machine 1? Is it the pressure? Is it the temperature of machine 2 or whatever? So this is everything we have to insert. We just click on OK, and we have our columns here as data points. And now the only thing we have to do is left click on the value element. You can do it anywhere here in this row. And hold the left mouse button down and move to the value target element and leave the mouse button. And we have connected to say the value of the current temperature should be saved to the value column of the process values table in the training database. And the same we do with the other columns, value time, and the config ID we don't get from the item name because this is a name, not a number. In my example, I know that the current temperature of machine 1 has a fixed value, so I can use the constant values object. Just double click to edit and insert the specific value. 1001 is the one I use for the temperature of machine 1. And then we do the same, we just connect the value 1001 with the config ID, and this is ready. We have a trigger, we have the sources, and we have a target to save the process values. Everything we now have to do is just set it productive. This means we now transfer the configuration. You see the new objects are all green. Configured objects would be yellow. and we send this configuration to the runtime service. This is just up for checking it to set it productive. And we now say, yes, everything is okay. And we want to set this connection productive. We also could select the connections we want to set productive and use the button here. But I prefer to directly use this button again. And now the connection is going to be set productive in the background, is starting running. And we can step over to the states tab. And there we see under connections, we have the same folder structure like all the set productive connections. And we have our temperature, machine 1 to database here. And we see a yellow line. This means that the connection has been initialized. And now the connection is ready and the trigger is waiting to for a data change on the temperature element. We also can see the service here, and the plugins can also be seen. So, sorry, it's not a cloud, it's a shop floor element. So we can also step directly to our target and source elements and see the status of this plugin. If we have changed something on the plugins, then we must select the service and say productive. And it asks us whether we really want to set the whole service productive. And we say yes. Okay, now it takes a short time until my connection is reinitializing. So that we can see that the data changes are running then. So now you see the connection is offline while restarting, and then there will come an orange dot instead of the offline element when it is ready to initialize the kernel of the OPC router, I would say. And then if it is ready, we will get the corresponding this circle, and the dot will get away. We also have the possibility, while we are waiting, to zoom in or zoom out of the timeline here. Yes. So you can select the specific timeline you want to have a look at. You also can use the mouse button here to scroll in and out. Yes, I use my mouse button. And if you use this zooming version or select a specific transfer, then this visualization will not be live. But you can go back to the live view if you click on this button here, and we see that it is running with a connection. So we have a green dot here and a new green dot, and on every data change, a new dot comes. And if everything is okay, it is green, and if there is an error, it would be red. If there is a warning, the dot would be yellow. In our case, everything is okay. Of course, it is a simulated machine, so it should be okay. And we see the connection here with all the transfer objects that we have configured in the data change trigger. And on each arrow, we see the value, the current value of the element. So we directly see what OPC router is transferring. And if there, for example, is an error on database side, we would see a red line here. And if you go with mouse over, we see an error line. Perhaps we can do some in the training later. And we can see the value and see, okay, perhaps we have a floating point number and want to save it on a Boolean column, and it would tell us that it cannot convert a floating point value to a Boolean element. I know that some people prefer not only having this great graphical view, but also want a table on the historical transfers. You also could select a specific historical transfer if you click on the dots here. But if you want to have a table, you can use this one here and select the time space, the time interval. And you have all the elements here, all the transfers, the timestamp, and the elements with the value. You also could use filtering possibilities, either with this filter element here or using a specific value. Perhaps if we, okay is not the something, perhaps we only want to see the item name value. So we can filter on the value, and we have the value time and the value. Then we also could change that. We can say equals or contains, does not contain, and so on. So we have now only the values, and we can see all the values of the past. And of course, we can export this view to a CSV file or an Excel worksheet or a text file to do some further investigations. Yeah, this is our first example already running. Any questions on this process values example?
For now, it's nothing in the chat. Oh, there's a question in the chat.
Yes.
Now, how could I set OPC UA such as a destination?
Okay, then you just would use the OPC UA as a target. We will do another example now if there's not any other specific question that would do this thing that is questioned or asked. So we can create a new connection here. And in the next example, we perhaps could send the corresponding production order to the PLC from the database. So we have in the database, we have the production orders, and we want to send the current production order to the PLC, and of course, receiving the process values. And later we can receive the corresponding confirmation of the production order. So we have a conclusive example here today. So I could name this connection sending PO to PLC. So in this example, we perhaps can start with a database as source. We can do the trigger in this example later because we use the trigger in addition here, not connected with the transfer object. As I told you before, this is also possible and normally the normal case. So we have our database transfer object, and of course we use the training database, and in this case we want to select the corresponding current production order from the corresponding table. So we have our table production orders, and we want to send the production order number, the target amount. I think this would be okay as first example, and or perhaps the target temperature, no. And we want to send this only for the machine 1. So we can add a filter here. In the preview, you can see this is a normal where clause from the SQL syntax. And we can create it here graphically, so you don't need to use the specific syntax here. And we want to use the line, the production line, as filters. So we use line 2, for example, and this can be filled dynamically during runtime. So we don't need to insert a value here in this step. We do this a bit later. Also, we can decide in which, perhaps in our example, yes, we use only one production order number sent to the PLC. If you want to send more than one, then you should use arrays on the target side, on the OPC side. And then it would make sense perhaps to sort something ascending according to the ID, to the plan start, to the transfer state, or whatever. Then we can decide what to do with the data that we already transferred with the OPC router. So we read the data and then we transferred it to the PLC, and what to do next. So perhaps we don't want to change the records, then everything stays the same. But in our example, we want to say, yes, we transferred it to the PLC, either successfully, then the OPC router itself would write value 1 to the database record, to the production order. or there was an error during transfer, perhaps PLC is not available or whatever, then we get the value 2 to our column. So we can use the transfer state column to mark the corresponding transfer. Then, of course, there's the question, which is our value for please OPC router transfer my production order to the PLC. The 0 is just an option that we normally use. So we can use the filter column here, not only the line, but also the transfer column. So we have the transfer state. If the transfer state is 0 and the line is 2, then we want to get the record sets with the columns production order number and target amount, and we want to mark the records in the transfer state column. So if there is no record set available, in our case, this could be because not always the program or the worker wants to send a production order to the PLC. So we would say abort transfer, this is okay. We don't always have one. If you want to request some recipe information to a production order, then of course there should be one, because having no recipe to a production order that you want to produce makes no sense. So then you would use return read error, or you just can return an empty record if you want to still send some value, some initial value. And according to that, we want to only send one production order to the PLC because we do not use arrays in my example. So we can say, please limit the number of records to 1. So the production orders would be sent one by one after each other. Okay, so we now have our filters for line 2 and transfer state 0. So these are fixed values. So we also can use the constant values object. Just double click 0 and 2. Okay, and we would send the 2 to the line, and you see per default it sorts automatically, so we get no cross arrows. Sometimes it takes a short time, you see, so you see that it works. And the columns that we want to send to the PLC are the production order and the target amount. And then we have the OPC transfer objects. According to that, we just want to connect to some data points using the current value. We use the OPC data access transfer object. If you want to call a method, for example, if you have a Euromap77 OPC UA server, then you could use the methods object, or if you have a structure, you use the OPC structures object. So we double click on OPC data access to configure it. Just select the OPC server that we want to connect to. And with the tag browser, we can select the corresponding elements. So under machine 1, PLC, under production data, we have a folder target data, and directly under production data, we have the product ID. This is the production order number, and the target amount would be the target amount under target data. Okay, so now we can go to the PO column, use the left mouse button and leave it over the target element. And with the target amount, you can do the same. And now all the elements are connected that we want to transfer. Perhaps for those who are new to the OPC router, perhaps there's the question how OPC router knows in which direction it should work through these elements. Of course, for us humans, it is clear to first send a constant value to the database and then to the OPC data access. And the OPC router does the same. If there is a pre-object, an object before, when arrow comes to the target object, then it would use this first. And if this is not clear, it starts from the left top to the right bottom. So we can use under information to show transfer steps for those who are new to the OPC router to make it clear. So we see the step numbers, how the objects are worked through. So perhaps it is a bit easier. So if you do something after these steps, you just draw this below. So perhaps we can do this by using a constant value, inserting it here. I just insert the value 1. And we use the OPC data access element again. We connect to the OPC server, and we use something that we use as a call as data ready. So this is some kind of trigger for the PLC. So if this data ready bit is set, the PLC knows that all the information for the production order, that it has received all the information for the production order. Yes, so in the first step, the production order data are written, and in the next step, the flag is set. So PLC, now please read out the data. And you see, according to the number 4, that it will be transferred after these first 3 objects. If I would draw it before or on top, then you see it would change its transfer step number to 1 and 2. So we first would set the data ready bit and then send the production data. So this is nothing we want to do. We just want to commit. Now please take the production order data and start producing. Of course, we still need a trigger. We say that in the database, we want to say now please transfer. So we use a database trigger for this example. Just double click and select the database connection. Then we have the table production orders where we see, okay, this is my production order. And if the transfer state changed, because this is the column where I mark if I want to transfer it or not, in the easiest example. So we use the column transfer state. So if this changes, we want to trigger a transfer. But we don't want to trigger this for all the lines, but for line 2, as we said before. So I would select the line, and according to that, this is the trigger. We don't use dynamic values during runtime, so we insert the corresponding value to here. So we have here the trigger. If line equals 2 and the transfer state changes, then please trigger the transfer. And what we do here is just to pre-select whether the transfer state is 0, because only if it is 0, we want to transfer the values. And of course, we also make sure that it is line 2, because the database trigger and the database transfer object are not connected. So we now can set the connection productive. You see the green objects and arrows and so on. And we now have a look at the state, sending the production order to the PLC, and we see that it is already initialized. It starts with an initial transfer because it could be a data change, and we see there's no corresponding production order at the moment. This is what I told you before. Perhaps sometimes we don't have a data change that is relevant. So we filter it here and we just get a warning, this is no problem. So now we step over to the database. So I have here my Microsoft SQL Server Management Studio, and I have my SQL Express server. I have my training database with the tables, and I have my production order tables. And if I right click and say edit top 200 rows, I could select a production order at line 2 and say, please change the transfer state to 0. Then we have a target amount of 10,000 and production order 145. And if I leave the line, the data change will set. And the OPC router is transferring the data. So what you see here also is we have a green dot because we changed the transfer state column. This is where the trigger reacts. Then the filter comes to the production orders table, asks for transfer state 0 and len 2, gets a value entry, and we get the production order 145 and 10,000 elements as target amount, and it is written to the PLC, and afterwards the flag data ready is set. So now the values are written to the PLC, and the OPC router actualizes the record of this production order and sets a new state. So if I actualize it here, this is not done automatically here in this tool. So we see that the transfer state is 1 because it worked. If it wouldn't have worked, there would be a 2 instead of 1. So if you if it changes to 1, it also triggers, because we have no value filter, it also wouldn't work. So please don't try to use the transfer state column in addition as filter, because this would be ignored for this column, because this is the data change column. And then the OPC router again filters for 0 transfer state in line 2, doesn't find an object, this is the one here, and stops the transfer or aborts the transfer. This is okay. So this makes sure that you get all changes and only get the relevant record sets. If there would have been another object, you would have get it in this case. So you don't miss any changes, especially no relevant changes.
We have one quick question.
Yes, according to the difference between connection arrow modes. Yes.
Yes.
I have seen, and I want to answer it now.
Perfect.
Because if we draw the arrows, we have the possibility to create a single arrow. This is what I do in this example, because there are just some arrows, not many. If you have many arrows, it would be much work. So we also could say, if you have 2 objects, please create a multiple connection arrow once. So if I select it and I draw an arrow, then it would draw 2 arrows if, just a moment, if it can, oh yes, I see I have done something wrong before, so it was correctly with the automatic, so I can use it once again. So if I send the production order, the PO is sent to the product ID and the target amount to the target amount, because they have almost the same name. So there's some intelligence in OPC router that you can draw more than one arrow at the same time if you have many objects and the names are almost equal. For example, if it is called here PO and here PO number, then it also would draw this connection. If I don't want to do it just once, but always, then I use the create multiple connection arrows. Okay. You're welcome. Good. So now we have done sending some process values to the database. We have done an example for using data change trigger, sending it to the database. And the third example would be sending from OPC to, sorry, we have the third example would be how I could use some handshaking, specific handshaking, sending data from PLC to a database, for example. Target can be replaced. You can replace each transfer object by another, just have some elements here and replace it. I see there's just one other question. How to use scripts with multiple read and multiple write. I think this is something that is not for the basic training. Perhaps we could connect to each other after this basic training here, I think. Okay, I think we can do the last connection example. So I would send it PO confirmation. So in this example, I would start with a trigger. We have two possibilities for good handshaking. The one is a bit trigger. So we double click, select the OPC server, and with the three dots, we could select the bit that triggers the connection. So we have under production data handshaking, the bit handshaking, trigger bit. And we can decide what to do if the data transfer is ready from the OPC router, as we have with the confirmation in the database trigger. We can do the same with the bit trigger on OPC side, but there are different possibilities. Either we can reset the bit. This would be this option. Then the OPC router would reset the bit. Or, according to our project engineers, it would be a better way to set an answer bit. So we can use the three dots behind the item of the answer bit and double click on answer bit to insert it or apply. If it is reset by the PLC, everything is okay. If the PLC does not reset it, you could say, please reset the after bit after perhaps 2000 milliseconds or something like that. And if an error occurs, we can use the error bit, use the three dots and select the bit handshaking error bit as target. Sometimes we have an old machine that is already programmed and you cannot change something on the program itself, and there is no possibility to set an answer bit or an error bit to quit or acknowledge that you have transferred the value. Then you could use the waiting for falling edge instead. So if the bit goes to true, the OPC route triggers, and it would trigger as long as the bit is 1. But if you want to trigger once, you can set this element waiting for falling edge. You also would get an information that the bit needs to be 0 for at least 1250 milliseconds, for example. This is 2.5 times of the 500 milliseconds, yes, that we have inserted as update rate for the tags here, to make sure that the OPC router recognizes the change from 1 to 0 and can again react on the change from 0 to 1. But in the best case, you have a bit trigger bit and an answer bit and an error bit. The data transfer would be as easy as before. We have an OPC data access where we have under our OPC server with the tag browser, we select the product ID. This is the production order number. We have the current data with the current amount and the current temperature, for example. And we can say, okay, now we have 3 elements to transfer, and the target object would be the database in our example again. So we would double click, and instead of insert, we would update the existing production order. If you want to check whether it is already existing to make either insert or update, then you should use the start procedure that you should prepare before. So we can say production orders is our target table, and we have the production order number. Oh no, not the production order number. We would send the target, the current amount. And okay, the current temperature is not available, so we would use the current amount as element here. And we would filter the current production order by the line here and the current production order from the PLC. So what to do next? We just connect the current amount to the current amount column, and the product ID would be set to the filter for the production order number, and the line is fixed because we know that we have line 2 here. So we can send the constant value of line 2 to the line and say set connection productive to set it productive. Yes, so we have our source elements for the current production order, including the constant line 2 value. We save it to a database table, the production orders table, where we have received the production order before, and the bit will be set to trigger, and if OPC router is ready, he will set the answer bit to 1 and the error bit also to 1 if there is an error, or to 0 if there is no error. So we can step over, and you see the trigger bit was already 1. We also could use a quick client to check that these values are right. So we can connect to the local CAP server here, which I'm connected to. Select machine 1, PLC, production data, handshaking, bit handshaking. We have the trigger bit, error bit, and answer bit, and we have the product ID, and under target data we have, no, not target data, sorry, current data, we have the current amount. I will narrow it a bit so we can see both. And you see the trigger bit sometimes raises to 1, but as long as the answer bit is still set, the OPC router would not send a new value. According to that, normally it is written by the PLC. I would reset it to 0. And as soon as according to that, the trigger bit was already to 1, it reacted again. So we have the new green dot and we see the value. And if I would reset it again, as soon as it is 0, just a moment, we can see the effect a bit better. Yeah, so it goes to 1, and then the answer bit goes to 1. Okay. Great. So I see the bit trigger is one possibility. So I just would copy my connection and paste it again to show you the message trigger, because I think this is one of the important triggers for this confirmation. So here you also select the OPC server and you select the trigger item, but this in this case, you don't have an bit that goes to 1 if you want to transfer data. We have some kind of counter, so it raises up if we have a new transfer, and the OPC router does the transfer, and then it can write an answer, and it cannot only answer with a bit. Now I'm ready. It also answers with a number, with the current count that it gets from the OPC server. You also could write an error bit. In my example, I think I will leave it out in this case. And we can decide whether we always want to trigger at start. We have seen on the data changed and on the table that it would trigger once at the beginning, because we have a kind of counter, so we don't know has it changed or not. So we can either say never trigger at start. This means when the connection starts or the OPC router starts, or always when it starts. But the best way I personally think is that if the message ID, this means the message trigger value, and the answer tag value are different. So perhaps you have a 4 for the message ID and a 3 for the answer ID at the beginning. So it would just trigger directly at the beginning. So if you set it productive, we can see we have the message connection here, and it just triggered once. You can see in the background, if I add this element here, new item, production data, handshaking, message handshaking, we have the message trigger and the answer tag. You see that the message trigger always counts up, and then the OPC router answers with the same value. So what makes it better than the bit trigger? The bit trigger only sees, yes, OPC router has answered, but if you have the counter, so perhaps the message trigger has value 2, and the OPC router starts transferring, and the message trigger thinks, or the PLC thinks, oh, nothing, no answer comes from the OPC router, so I should increase my counter again. So it increases the counter to 3, and now the OPC router answers, but it doesn't answer with a 3 because it has still worked with a message trigger value 2. So it responds with a 2, and the PLC sees, okay, there is a new value, but the new value is not the same as my message trigger is. So this was an old transfer. Yeah. So this is one step better than the bit trigger if you can use it in your connections. Okay, I think this should be for a first step into OPC router for first basic training, because I'm running out of time, Torsten, right?
That is correct.
Yeah, so enough for basic, enough stuff.
Okay, so thanks all of you for your patience. I think we have a few questions still. One question from Bart is it possible to insert your own scripts? Yes, it is. Not sure if it's something you can show in a few seconds.
Perhaps I can have a look. We have under advanced the possibility to create some scripts. So we have scripts for triggering. So for example, I have one threshold script trigger. There we have some methods inside. The first one is the check trigger, when to check the trigger, what to do if we check the trigger, especially in this example, every 5 seconds, 5,000 milliseconds. So if the value exceeds the configured threshold value, then return true. So this means the OPC router trigger should trigger, and else it should return false. And after the transfer has taken place, we also can do something like with the bit trigger or message trigger we have seen. So we can do something after the connection. So if there was a transfer error in my example, there would be a little log in the log file. And if there is not a log file, I would save a value in this example.
Okay, so the answer is we can work with individual scripts within connections, but also we can you have the opportunity to create your own plugins if there should be a device which is not directly supported by OPC router. Now you can also create your own plugins using scripting. If you should be interested in that, just let us know, shoot us an email, and we will tell you how that works. There is another question regarding coming from Stefano. How could I set the database trigger on the last row edit in my table, supposing that this table is updated adding a row?
This is a little bit difficult because each data change also means this could be an insert, an update, or yes, an insert or an update. So you cannot easily say it's only for insert. I think perhaps we should have a look at the example then, the specific example.
Okay. So maybe Stefano can, I guess he's coming from Italy, can get in contact with EFA in Italy, our partner in Italy, and then we can help you find a solution for your request.
Perhaps you could add an additional transfer state column then to make sure that you get the right record set as I did here. Then only the new record sets would have the initial value.
Okay. Then there's a generic question from Tazaka about what kind of interfaces are accepted. So what kind of plugins are available? There are more than 40 opportunities to connect different systems. So the easiest way to find out which are supported would be to go on the OPC router website under opc-router.com. And there's a section called plugins. And if you click on that plugins link, you will get you will be connected to a plugin overview where you can see all the plugins like Euromap, REST, MQTT, databases, printers, barcode readers, RFID systems, SAP connectors, ERP solutions, SOAP web services, and so on and so on. So there are about 40 connectivity opportunities for OPC router. And one last question coming from Dimitri. May we use OPC router as historian for logging 1,000 or 5,000 up to 5,000 tags or even more each second? What are the limits? As I understand the question, I would not use OPC router as the historian, as it's not working with an historian database. With one of the next releases, we will add a new database as a project database for OPC router. We will then work with MongoDB as OPC router project database, which is quite performant. But I would say that you still use an historian database or another database and only use OPC router to transfer that data into that historian database, which could be InfluxDB or any industrial historian like OZPy or Wonderware historian, or I think also Siemens and GE have historian solutions. From my perspective, it depends what kind of value these are to, which should be transferred into the database. How complex the request is, how big the data is that needs to be transferred. But in general, I would think that 1,000 tags per second should not be an issue if these are just values. Or how do you see it, Andrea? Would 5,000 tags be a problem?
No, it really depends on the surround systems. But if you use, for example, because we don't save the values in the OPC router configuration database itself, but if you use an InfluxDB, for example, as a very high performance target system, then it should be possible. I would not use a classic SQL database because it could be slow. Even thought it would be possible it could be possible to log 1,000 to 5,000 tags. We have customers doing that, but if you have 5,000 tags, for example, in the full project, then it doesn't mean that all 5,000 tags would be changing every second. So you can use the triggers, the trigger possibilities to optimize that you only get the relevant changes and then save the values to the target systems. And if you use an InfluxDB, for example, that could be very fast.
Or you can transfer them by batch. So not every single tag, but maybe every 5 seconds a batch of all the values that have occurred until then with timestamp.
Yes. But
So,
depending on the performance of the server system below and the target database system and the source OPC systems, this should be no problem. We have other customers doing more tags, but it really depends on the system.
okay.
And there's the last question I see. If we have a plugin for communication with Serba scales or labelers, yes, we can do that. We have no Serba plugin for that, but there are different possibilities. So perhaps we can have a little discussion afterwards. What's the best way for your example? But Serba is something we often have in at our customers.
We have, I think we also have 1 or 2 native drivers for scaling systems, but I don't think for Bizarre. But yeah, as we could do it with other scales, I think we can also do it with Bizarre scales. And labelers should not be a problem because we have a generic printer plugin, for example, that could solve this. Oh, do you, Andrea? Do you know the scale? Was it mezzo?
Yes, for example.
I think mezzo.
But also Serba.
Okay, so we have experience there. Just shoot us an email, and we can find out how to help you with the server scale. Okay, yeah, we are 13 minutes over the time. So thank you very much for your participation. I will once again share my slides, but only to thank you very much. If you should have any questions regarding the scales or which kinds of plugins you might need for a special case, just contact your local distributor. You can find them under on our OPC Router website under the international distributors link, or send us a direct email at sales@inray.de, and we will be happy to connect you with your partner and answer your question directly. So thank you very much for your participation, for your patience, for your interest. Wishing you a good day and a good night. Thank you very much. Hope to speak to you all soon. Bye-bye.
Bye-bye.
I think we can stop the recording now.
Yes, of course.